Hey, so I want to talk for just a second about connections. A lot of times you don't realize when you're taking a test, a lot of you kids don't seem to realize that the things in this test are connected. You'll start working on this right here and you don't realize that we've just done half the problem up here. It says to find the least common multiple of 210 and 12. To find the least common multiple, we simply have to use these prime factorizations. And so it's already done for you. So try not to work too hard and use what you've already done in the next sections. Now, one thing you need to understand is I circled a lot of this right here on your tests. M means multiple. A multiple is a number that's larger than both of these that they both go into. So it can't be less than 210. It has to be a number that's at least as big as, if not bigger than both of them, that they both go into. Okay, they multiply into whatever number that is. So a lot of you guys put like 4 and numbers smaller than that. No, those are factors. Numbers that are smaller that go into both of these are factors. The multiple is a number that's bigger that these both go into. But it's the smallest one we want. Some of you guys multiplied 210 times 12 and wrote that down. Yes, that is a multiple of 210 and 12, but it's not the smallest one. To find the smallest one, we have to stack these in columns, but we stack them in columns where the numbers are the same. So this first one, I have a 2 and a 2 and a 3, right? The second one, I have a 2. I don't have another 2, so I just leave that blank. I have a 3, and I have a 5 and a 7. All right? Once I've got them stacked, what that does is it makes it so that wherever there are duplicates, I don't use that duplicate twice. Now I'm simply going to list all of the numbers underneath here. That's a 2. That's a 2. That's a 3. But I only write 3 once because I don't want to duplicate it. That's a 5. And that's a 7. 2 times 2 is 4. Times 3 is 12. Times 5 is 60. Those of you who don't have your multiplication tables down, you better get them down. 60 times 7 is, 6 times 7 is 42. So 60 times 7 is 420. That is my least common multiple. Now, if I was to put this duplicate 2, if I put another 2 there and another 3 there, that would take me back to simply 12 times 210. It is a multiple, but it's not the smallest one. So what we've effectively done by stacking these like this is we've eliminated these, which gives me the smallest number possible that's still a multiple of 210 and 12. Okay. Now let's talk about the greatest common factor. The greatest common factor is the smallest, or the biggest possible number that goes into both of these. So I'm going to do the stack again. Same stack. 2 times 2 times 3. 2. My pen running out of ink. Heaven knows I've used it a lot correcting your tests. Times 5 times 7. Okay. Now, I'm going to do the same kind of thing, but not exactly the same. See, it's common factors. So I'm just going to look for the common factors. There's a common factor here of 2, no common factor there, no common factor there, no common factor there, but there's a common factor here of 3. Now I multiply both of those common factors together, and I get a 6. 6 is the greatest common factor between 210 and 12. Notice that it's smaller than 210 and 12, and that the multiple is bigger than 210 and 12. That's a really quick and dirty check to see if you got the right thing. Okay? It may not be correct anyway, but you at least know that it's not too big or too small. Now, a lot of you guys had trouble with this one. It says here, use prime factorization to find the value of square root of 576. Some of you said what does that symbol mean? It means square root. When you find the area of a square, you multiply a number by itself to get the area. This square root means what number do I need to multiply by itself to get 576? For example, the square root of 16 equals 4, because 4 times 4 is 16. The square root of 36 is 6, because 6 times 6 is 36. Well, what's the square root of 576? Oh, I don't know that off the top of my head. But there's a little clue right in the instructions. It says use prime factorization. So some of you, even though you didn't know what you were doing, you at least knew to do this. Okay? So I'm going to go 2 and 576 divided by 2. Let me do this. I have it right here in front of me, but I'm going to do this because I want you guys to see that it can be done with tools that you've been given for years. 288. Okay. 2 times 288. Well, that's just 2 times 144. And that's just 2. Well, let's go 12 times 12. And that's 4 times 3. And that's 4 times 3. And that's 2 times 2 times 3. And that's 2 times 2. So my prime factorization of 576 is, this is the same thing as saying the square root of 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3, right? You see that? Sorry. 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3. So there's 6 2's. 1, 2, 3, 4, 5, 6. And there are 2 3's. 1, 2. Well, here's the cool thing about factorizing like this. I know that the square root of 4 is just 2. I know the square root of this 4, 2 times 2, is just 2. I know the square root of this 4 is 2. And I know the square root of 9 is 3. And I know that 2 times 2 is 4, times 2 is 8, times 3 is 24. So 24 is the square root of 576. See, I just took out pairs knowing what the nature of the square root is. Square root of 2 times 2 is 2. Square root of 2 times 2 is 2. Square root of 2 times 2 is 2. Square root of 3 times 3 is 3. Multiply all those together, I get 24. Now try it. Put 24 times 24 in your calculator. You'll get 576 out.